Welcome to Bonhill Geography. In this revision video we're going to look at Earth's structure, tectonic plate movements, volcanoes and living near volcanic areas. Now the Earth is composed of several layers. We call these the crust, mantle, outer core and inner core. The crust is the thinnest of them overall. The mantle can be described as semi-plastic, so it almost feels like Play-Doh. The outer core is liquid, made from iron and nickel, and the inner core is also made from iron and nickel, but solid due to the pressure. The crust and the upper mantle form the lithosphere, which is divided into tectonic plates. Heat from the Earth's core causes convection currents in the mantle, driving the plate movement. This is where warm rock rises, spreads out at the top of the crust, moves across and then cools and sinks, waiting for the process to begin again. The second process for plate movement is gravity. This is where it pulls a subducting plate, remember that's a plate going into the mantle, further into the mantle. This is a process known as slab pull. There are four main types of plate boundaries. Constructive boundaries occur where plates move apart. This forms new crust, such as at the mid-Atlantic ridge. You can see a really good graphic of this in the background. Destructive boundaries happen when plates collide, and the oceanic plate is forced underneath the continental plate. We call that process subduction, that we've mentioned earlier. This forms powerful volcanoes and tall mountains when they become extinct. This is because when the oceanic crust melts, all of the molten rock rises to form the volcanoes, as we can see in the diagram behind us. This lava contains lots of carbon, which is what makes this process very explosive. Conservative boundaries involve plates sliding past each other, causing earthquakes. We can see examples of this at the San Andreas Fault. As a reminder, we're not going to see any volcanoes here, only earthquakes. Collision boundaries occur when two continental plates collide. This forms mountain ranges, like the one seen in the Himalayas. Remember, at this hazard again, we are not going to see any volcanic activity. It is primarily going to be things like our earthquake-driven focus, potentially even landslides. Now the Himalayas also experience lots of avalanches. These are likely to occur here because lots of snow forms on top of them given their height. Now let's look at volcanoes. These come in various types, each with their own distinctive features. The first we'll look at are lava domes. These are steep-sided and formed by viscous lava, such as Mount St. Helens. These are usually found near destructive plate boundaries or hotspots. This is because as the volcano is increasing in height, it's quite sticky, and so it just builds up on top of each other. Shield volcanoes are broad and very gently sloping. These are normally formed by low viscosity lava. This means that it's quite runny. This is a bit like Mauna Loa in Hawaii. These are usually found near constructive plate boundaries, but can also be hotspot volcanoes like the one seen in Hawaii as well. Composite volcanoes are steep and symmetrical. These are formed by alternating layers of lava and ash, such as the one seen on Mount Fuji. These are usually found again near destructive plate boundaries and are very explosive because the main vent commonly becomes blocked. This can lead to dangerous hazards like pyroclastic flows. Our next section explores living near volcanoes because they can offer several benefits to people that decide to locate there. The first benefit we'll look at is geothermal energy. This harnesses the heat from volcanic activity to generate electricity and provide free heating. This reduces the reliance on fossil fuels and lowers greenhouse gas emissions significantly. This is quite common in Iceland, where geothermal energy can also be used to heat greenhouses, to grow tomatoes. This would be impossible without the cheaper source of electricity and heat. Tourism attracts visitors to volcanic landscapes, geysers and hot springs. This can boost local economies through spending on accommodation, food and different types of activities. It's also important to mention that volcanic ash can enrich the soil. This enhances agricultural productivity and helps to support food security. We call this soil fertile soil, but it's important to remember that this can take hundreds of years to develop. However, there are significant challenges from living near volcanoes. For example, ashfall can disrupt air travel. This is because when it's in the jet engines themselves of planes, it can essentially melt inside the engine itself, turning into glass. It can also significantly damage crops and bury them under the ash, and cause respiratory problems if people breathe them in. We also have acid rain. This is formed from volcanic gases like sulfur. This can harm vegetation, stripping trees from their leaves and infrastructure. Pyroclastic flows are fast-moving, deadly flows of hot gas and volcanic matter. These can travel up to speeds of 400 km per hour. Lava flows can destroy property and infrastructure, with fast-moving lava posing greater dangers. They can also start fires, which can quickly grow out of control. Lahars, or mudflows, can be composed of volcanic debris, normally ash and water, and these can bury communities and infrastructure alike. This flows like liquid cement and is very difficult to escape from once you've been sucked in. Landslides can also be triggered by volcanic activity. These pose risks to settlement and can block roads, making rescues more difficult. Now let's look at the strategies to mitigate volcanic hazard risks, including prediction, protection, planning, and monitoring. Prediction involves monitoring volcanic activity using seismographs, gas sensors, and satellite imagery to forecast eruptions and earthquakes and provide early warnings. Protection includes constructing buildings and infrastructure to withstand volcanic events, for example using heat-resistant materials and designing buildings to withstand ashfall. For earthquakes, this could involve base isolation, where buildings can shake freely without collapse. You could also reinforce the walls with a steel lattice structure. Planning involves developing evacuation plans, conducting drills and educating the public about volcanic hazards. This includes anything to do with lava from the eruption itself, but also earthquakes. This means that people can evacuate quickly and safely without disruption. Monitoring is arguably the most important of them all. It uses technology to track volcanic activity and provide real-time information to authorities and the public. This means that they can evacuate these areas if needing to do so. This is for both earthquakes and volcanic eruptions. Other management strategies include earthquake-proof buildings, as we talked about earlier, lava walls which can be constructed to divert lava away from key strategic areas. For example, the town of Reykjavik, or city of Reykjavik in Iceland, they built lava walls around it to make sure that it doesn't come and flood the city with lava. Having good evacuation plans in place means people can get out safely and without damage or loss of life. Monitoring, as we said before, is essential because it means that we can provide timely data for evacuations to happen, and having a go bag ready by your door. This sounds silly, but it means that you are not trying to pack your essential items just before you need to leave your home, because sometimes we have hazards like pyroclastic flows which could literally devastate someone's house within a matter of seconds. As previously mentioned, earthquake-proof buildings use lattice steel frameworks, rubber foundations and base isolation techniques so the building can sway above the ground. They can also use counterweights to make structures more resilient to seismic activity. The counterweights themselves swing in the opposite motion to the motion of the earthquake. Here are 5 example questions you could be asked about this topic. Please do have a practice of them. On the following slides, there will be model answers for you to use, for you to check against your work. Thank you for watching Bonhill Geography. I'll catch you in the next video.